Welcome. I am Daisy, your hostess. I feel like it's been a little bit since the last time I expressed my gratitude to my family, my friends, and you, my fellow subscribers. Please know that I truly appreciate you and your visits and your comments. Having said that, these next series of chapters that I'm bringing to the channel through this book is a byproduct of my quest to bring to you stories of creation, no matter how they're wrapped, whether it's through the lens of science, theology, through poetry, you name it. And I'll give you the title to this book in a little bit. So far, I've brought to you the Epic of Atrahasis, the Epic of Gilgamesh, and these are Sumerian stories. And also, I brought stories from the Norse, the Gylfaginning, and we went all the way to the Greeks to visit with Plato's Timaeus, and then hopped over to the New Continent and met up with the Hopis of North America. So those are just a few to mention. I find it fascinating that for one planet there are so many creation stories, which gives me a moment for pause. And, given that most of these stories were considered myths or are considered myths and were passed down orally, it's interesting that, when you start compiling them together, they're in different parts of the world and yet they have some things in common. And the first documented writings of man is said to be emerged from ancient Mesopotamia, specifically from the Sumerians, and that was going back all the way to 3400 BC. So we'll find the stories like from Atrahasis written in cuneiform tablets. Yet with so many stories of creations, it's not a wonder, logically, that one would default to the sciences for answers. And when we look at the scope of man's progress, science as a formal discipline and practice through the method of employing scientific methods itself emerged around just the 16th century. This is not to say that man's curiosity did not lend to scientific thinking. Of course it did, but not as the way as we know it today. In ancient civilizations like Mesopotamia and Egypt, scribes and priests would have been the scientists of their time. Now, while science can explain many aspects of the universe formation and the development of life, which this author goes into beautiful detail in one of the later chapters, it cannot definitely explain the origin of creation. Don't take my word for it. With today's technology, you simply need to type the question in your favorite search engine, and this is the answer you most likely will get, because I did the search. Quote, "While science has made significant strides in explaining the origins of the universe and life, it cannot definitively explain the absolute origin of creation. Science focuses on understanding the natural world through observation, experimentation, and the development of testable theories, but it doesn't address the metaphysical question of a first cause or creator." End quote. I find it very frustrating, you see? Science has made a lot of progress in helping us trace life forms all the way back to the Big Bang. Yes, we're talking about the Big Bang theory. But has anyone answered the question, what was the initial trigger? And I can follow along with the idea of heat and expansion. I can get that. That's what they always get back to. But as far as the spark, how did that get there? Where is it from? But I even have to go and turn on the oven, if you get what I'm getting, So it appears that still today, the origin of the universe itself lies beyond the scope of what we scientifically can explain. It's almost like a big riddle, even as we discover quarks, which is said to have fractional electric charges and be among the smallest particles in the universe. And for all the scientific lingo when talking about electricity, defaulting to Einstein's equation of E equals mc squared, scientists use words such as inherent energy to be attributed simply due to an electron's existence, regardless of its motion or environment. Okay, so where did that energy come from? It's almost as the philosophical I am. It stands alone, right? And when you're asking that question to scientists, all you get is crickets. On the other side of creation spectrum, there is God. typically considered supernatural. And here, this is not to question anyone's faith. This is just to put it out there, just to have a conversation, right? And so therefore, the origin of a supernatural being falls outside the realm of scientific inquiry. So we can't go there through science. And most of it, as many religions, want us to take it on faith. Don't question, just take it on faith. And so I bumped into this book by Charles London Arnold titled Cosmos, the Soul and God. While it's not a story, the author attempts to bridge scientific insights and metaphysical reflections, offering a new perspective on the interconnectedness of all existence, mentioning a few scientists and philosophers along the way from older and contemporary times. So in this video, we crack open the author's argument and welcome his first chapter, as he walks us through the interdependence of science and philosophy, astronomy, and other sciences, bringing us back to the basic understanding that Rome was not built in one day, walking us through the gradual birth of these earlier sciences. And in doing so, he explains even an apple falling on one's head, when presented through the light and the lens of science, can offer one of the biggest breakthroughs for continued evolution of sciences and humanity, as we continue to know ourselves. Yet, of particular interest to me is a topic that most religions embrace, and it's to be taken on faith, is the essence of God. While I may clarify that the author in this chapter is not describing God, but this is where I say that science and religions kind of merge, or theology if you want to say it that way. It's in the scientific explanation of the indestructibility of matter, and through the scientific method and under the title of natural law, it explains that nothing is lost. So if you've ever questioned, will I live forever? Will you live forever? Well, according to science, one could demonstrably prove that matter is never lost, but more so transmuted. And then comes the question of, what about the soul? We'll get into that as we join the author in some of his later chapters. And guess what? We go back into the rabbit hole. And as I now turn the page, please do let me know that you are here. Hit the like button, leave me a comment, and yes, subscribe to the channel. Cosmos, the Soul and God. A monistic interpretation of the facts and findings of science by Charles London Arnold, M.A. Preface. Permission have been granted by Sir Oliver Lodge to embody in the preface of the present book certain passages from his recent important work, Life and Matter. The author takes this opportunity to express his profound gratitude to his benefactor for the great privilege accorded him. This eminent scientist, in the book from which the following quotations are made, has rendered a most valuable service to the cause of truth, not only in exposing the speculative fallacies of Professor Ernst Haeckel of Jena, but in suggesting certain fundamental philosophical principles and their application to the solution of many hitherto insoluble problems of the universe and of human experience. It will readily be seen by the reader how fittingly these quotations are made to constitute a preface to this volume. Before everything, a philosopher should aim to be all-inclusive. Before everything, a man of science should aim at being definite, clear, and accurate. An attempt at combination is an ambitious attempt which may legitimately be made. Positive contributions either to fact or to system may be real and should be welcome. The problem to be solved, and an old world problem indeed it is the range and especially the nature of the connection between mind and matter, or let us say between the material universe on the one hand and the vital, the mental, the conscience, the spiritual universe or universes on the other. It would be extremely surprising if any attempt yet made had already been thoroughly successful, though the attack on the idealistic side appears to many of us physicists to be by far the most hopeful line of advance. An excessively wide knowledge of existence would seem to be demanded for the successes of any such most ambitious attempt. But, though none of us may hope to achieve it, many may strive to make some contribution towards this great end, and those who think they have such a contribution to make, or such a revelation entrusted to them, are bound to express it to the best of their ability and leave it to their contemporaries and successors to assimilate such portions of it as are true and to develop it further. It may be worthwhile to explain how it is that, to a physicist unsmitten with any taint of solipsism, a well-elaborated scheme which is consistent with already known facts necessarily seems to correspond or to have close affinity with the truth. It is the result of experience of a mathematical theorem concerning unique distributions. For instance, it can be shown that in an electric field, however complicated, any distribution of potential which satisfies boundary conditions and one or two other essential criteria must be the actual distribution, for it has been rigorously proved that there cannot be two or more distributions which satisfy those conditions. Hence, if one is arrived at theoretically or intuitively or by any means, it must be the correct one, and no further proof is required. So, also, in connection with analogies and working models, although they must necessarily be imperfect so long as they're only analogies, yet the making or imagining of models, not necessarily or usually a material model, but a conceptual model, is a recognized way of arriving at an understanding of recondite and ultrasensorial processes occurring, say, in the ether or elsewhere. As an addition to evidence derived from such experiments as have been found possible, and as a supplement to the experience out of which, as out of a nucleus, every conception must grow, the mind is set to define and invent a self-coherent scheme which shall imitate, as far as possible, the results exhibited by nature. By then using this as a working hypothesis and pressing it to extremes, it can be gradually amended until it shows no sign of discordance or failure anywhere, and even serves as a guide to new and previously unsuspected phenomena. In the transcendental or ultramundane or supersensual region, there is the further difficulty to be encountered that we are not acquainted with anything like all the boundary conditions, so to speak. We only know our little bit of the boundary, and we may err egregiously in inferring or attempting to infer the remainder. We may even make a mistake as to the form of function adapted to the case. Nevertheless, there is no better clue, and the human mind is impelled to do the best it can with the confessedly imperfect data which it finds at its disposal. The result, therefore, in this region is no system of definite and certain truth, as in physics, but is either suspense or judgment altogether, or a tentative scheme or working hypothesis, held undogmatically in an attitude of constant receptiveness for further light and in full readiness for modification in the direction of truth. So far concerning the ascertainment of truth, alone in intangible regions of inquiry. The further hypothesis that such truth, when found, will be most satisfactory, or in other words, higher and better than any alternative plan, the conviction that faith in the exceeding grandeur of reality shall not be confounded, requires further justification, and its grounds are not easy to formulate. Perhaps the feeling is merely human and instinctive, but it is existent and customary, I believe, among physicists, possibly among men of science in general, though I cannot speak for all, and it must be based upon a mass of experience in which, after long groping and guesswork, the truth has ultimately been discovered and been recognized as very good. Life may be something not only ultra-terrestrial, but even immaterial, something outside our present categories of matter and energy, as real as they are but different, and utilizing them for its own purpose. What is certain is that life possesses power of vitalizing the complex material aggregates which exist on this planet, and of utilizing their energies for a time to display itself amid material surroundings. And it seems to disappear or evaporate whence it came. It is perpetually arriving and perpetually disappearing. While it is here, if it is at a sufficiently high level, the animated material body moves about and strives after many objects, some worthy, some unworthy. It acquires thereby a certain individuality, a certain character. It may realize itself, becoming conscious of its own mental and spiritual existence, and it then begins to explore the mind, which, like its own, must underlie the material fabric, half displayed, half concealed by the environment, and intelligible only to a kindred spirit. Thus the scheme of law and order dimly dawns upon the nascent soul, and it begins to form clear conceptions of truth, goodness, and beauty. It may achieve something of permanent value, as a work of art or of literature. It may enter regions of emotion and may evolve ideas of the loftiest kind. It may degrade itself below the beast, or it may soar till it is almost divine. Is it the material molecular aggregate that has of its own unaided latent power generated this individuality, acquired this character, felt these emotions, evolved these ideas? There are some who try to think that it is. There are others who recognize in this extraordinary development a contact between the material frame of things and a universe higher and other than anything known to our senses. A universe not dominated by physics and chemistry, but utilizing the interactions of matter for its own purposes. A universe where the human spirit is more at home than among these temporary collocations of atoms. A universe of noble contemplation and of lofty joy. Long after this planet, nay, the whole system shall have fulfilled its sphere of destiny and retired cold and lifeless upon its endless way. These eloquent words from the pen of one of the most widely recognized authorities upon the questions of modern science may be thought by some to constitute a grand and magnificent vestibule to a rather mean and unattractive temple. It may even be that many who read these words of great worth will proceed no further with me, but seek the instruction rather of that master of science. Should this be so, only good could result. However, I think I have rightly placed these quotations in the very forefront of my book, for they afford me the strongest evidence I have yet met with in scientific literature that I have not been following an ignis factus through the past quarter of a century. I feel confident that the reader will readily perceive that I have pursued the line of thought and investigation indicated in these quotations, and set forth a somewhat comprehensive hypothesis firmly based upon principles therein suggested. It may be regarded as bold and presumptuous on my part to seem to claim that I have in a measure realized the attempt to solve the old world problem as to the range and especially the nature of the connection between mind and matter. Or let us say, between the material universe on the one hand and the vital, the mental, the conscious, and the spiritual universe on the other. The excessively wide knowledge demanded for the success of any such most ambitious attempt is certainly at one's command in this marvelous age. The facts established by the great scientific investigators of the past century, as set forth in the introductory chapter of the present work, constitute a vast store of knowledge provided with which a thinker of today may go forth to achievements heretofore altogether impossible. I think I make it clear that there has been consistent progress in all departments of science toward the discovery of the limitations and boundaries of the physical world, establishing the necessity of postulating the essential psychical or spiritual nature of the universe or cosmos, and distinctly proving that the present physical world or process is finite, transient, and but a phase of cosmic activities without manifesting anything of agency originating within itself. Hence, in no sense self-explanatory or accounting for its own activities. Had it been permitted to Spinoza to have at his command all the rich treasures of fact which modern science has gathered and given to the world in such comprehensible and usable form, that great philosopher would have formulated a universal philosophy which would still command the assent of all men. His philosophy was founded upon the facts of the universe as they were then certified to him, and his method was that of seeking to interpret these facts rationally and consistently with all human experience. Before everything, I have sought to develop an all-inclusive philosophy, starting with the established facts of science, seeking the causes of manifested phenomena, tracing the causal series to the very limits of scientific investigation, inevitably finding at the limits of the physical process an effect for which no physical cause can be discovered, and driven to attribute such effect to some agency outside the world of sense, I reach at length the inevitable conclusion that there is a world or universe out of which this physical process comes, upon which it rests, by which it is energetically sustained. In a word, that the present world is but the phenomenal representation of some of the forms of cosmic energy. The physical world embraces that region of the universe whose phenomena are apprehensible by our senses. Its boundaries are the limitations of our actual and possible sensible knowledge and experience. It is a process identical with the process of evolution. In the order of development, it ever manifests higher and higher forms of cosmic energy. The process of evolution is, therefore, a physical process only. All progress is manifested in the origin, development, and improvement of material conditions, aggregates, compounds, and physical organisms and organs. The atoms, molecules, mass, and all aggregations, large and small, are within the physical world. All forms of energy capable of being scientifically investigated, such as gravitation, cohesion, chemical affinity, heat, light, and electricity, constitute the activities of the physical process. The phenomena of life and mind, too, so far as capable of being apprehended by our bodily senses, belong to the material order. In all this region we observe the progress of evolution. Atom, in accordance with definite laws, unite into molecules. Molecules constitute mass. Mass is divided into innumerable material forms. These forms are aggregates of molecules having many different properties. Out of these, the nebula, the suns, the planets, all terrestrial bodies, all organisms are formed. The process of evolution is that of the formation and transformation of all these material forms. What is sometimes called mental and spiritual evolution is only the manifestation of higher psychical or cosmic forces as the process of evolution brings forth the more highly developed physical organisms capable of responding to and manifesting these higher forms of spiritual energy. The cosmic hypothesis, which it is the purpose of this book to set forth and establish, may be briefly stated as follows. The universe or cosmos is infinite, eternal, infinitely energetic, and essentially psychical or spiritual, and perfect from everlasting to everlasting, the objective to God. It is God's creature in that it exists because God exists. All forms of so-called physical energy are manifestations of cosmic and psychical forces or activities. The theory here in advance accounts for all the facts of science and all the items of human experience. It offers a coherent scheme of scientific knowledge into which there are no things which cannot be fitted. No possible advance of science can render this hypothesis inapt, invalid, or obsolete. It disproves materialism by offering a more satisfactory explanation of its own fundamental principles. It substitutes for idealism a consistent, comprehensive, and rational theory of the universe as real, eternal, infinite, and psychical. The doctrine of evolution determines man's place in organic nature. The hypothesis here presented designates the place of organic nature in the course of the development of the Earth. The Copernican theory determined the place of the Earth in the physical world or process. The theory here offered determines the place of the physical process in the infinite and eternal cosmos. In the discussion following, we recognize the two paths which alone can lead to the solution of the great cosmic problems, experiment and speculation, as of equal value and mutually complementary. It must be admitted that pure speculation cannot bring us to the knowledge of reality. On the other hand, the bare facts of science, out of relations with all other facts of the universe and of experience, present us with a world composed of a heap of dead atoms. Our endeavor has been, and will ever be, to make due use of the recognized results attained by the great progress of anatomy, physiology, histology, ontology, and all other branches of science as the fundamental basis on which to build a permanent and enduring superstructure of legitimate speculation. Without wasting time in discussing a theory of knowledge or a system of epistemology, as was recommended to me by a critic of my manuscript, I am satisfied to accept as reliable and irrefutable portions of truth the facts which science warrants to us as such. Reasoning from the facts consistently with experience, my method is to construct of them, as imperishable blocks of truth, a theory of the universe into which all cosmic facts and incidents will fit without manipulation. The test of the truth and adequacy of this theory is its power to account for all the facts. Signed, C.L.A. Detroit, Michigan, January 1st, 1907. Chapter 1, Introductory. A quote by Ernst Haeckel. The great progress in anatomy, physiology, histology, and ontogeny has recently added a wealth of interesting discoveries to our knowledge of the mechanism of the soul. If speculative philosophy assimilated only the most important of these significant results of empirical biology, it would have a very different character from that it now unfortunately presents. End of quote. A quote by G.J. Romans. Although science is essentially engaged in explaining, her work is necessarily confined to the sphere of natural causation. Beyond that sphere, i.e. the sensuous, she can explain nothing. In other words, even if she were able to explain the natural causation of everything, she would still be unable to assign the raison d'etre of anything. End of quote. Another quote by G.J. Romans. If science could transcend the conditions of space and time, of phenomenal relativity, and of all human limitations, only then could science be in a position to touch the supernatural theory of religion. But obviously, if science could do this, she would cease to be science. In soaring above the region of phenomena and entering the tenuous ether of noumena, her wings, which we call her methods, would in such an atmosphere be no longer of any service for movement. Out of time, out of space, out of phenomenal relations, science could no longer exist as such. Such then I conceive to be one of the most important consequences of the monistic theory, namely that, by regarding physical causation as everywhere, the objective or phenomenal aspect of an ejective or ontological reality, it furnishes a logical basis for a theory of things which is at the same time natural and spiritual. End of quote. Quote by Professor Peabody. Nothing, after all, is of such permanent worth as a rational interpretation of the universe. End of quote. Philosophy is an attempt as far as possible to know the universe as a whole. In modern times, the so-called natural sciences occupy a vast portion of the ancient domain of philosophy. These special sciences deal with facts from their several special points of view. They severally investigate several fields of phenomena. Physics, in its narrower significance, treats of matter, its properties, of mass, molecule, and atom, of the forms of energy, heat, light, electricity, sound, and of the laws of motion. The student of physics invades the domain of other sciences. He studies the nature of solutions in physical chemistry. He trespasses within the boundaries of astronomy in his researches in astrophysics. He investigates earthquakes, volcanoes, etc. in geological physics. All the sciences are attempts to know certain portions or phases of nature or the physical world. They seek to investigate the facts and phenomena of the material process as these are discovered through the senses and to classify and unify the discovered facts. The physical sciences claim the right to carry their investigations throughout time and space so far as their methods of observation and experiment will enable them to search. Gross matter, the subtle ether, the heavenly bodies, near and remote, all forces and forms of motion, the chemical elements and activities, life in all its manifold manifestations, biology and physiology are all within the domain of the natural sciences. It would be wearisome to enumerate the ever-increasing branches of science in our day. Philosophy attempts to unify all these several classifications of phenomena and to fashion them into one comprehensive and consistent system of things. Philosophy seeks fundamental principles and to interpret the facts gleaned in all the diverse fields of science consistently. Philosophy may not disregard the findings of science and build castles in the air. The facts discovered by patient investigation and the theories verified and established by science must be accepted as the sure foundation for any enduring system of philosophy. Speculative philosophy must assimilate the most important of the significant results of empirical science in all its departments, if it would offer any comprehensive or intelligible view of the universe. The oldest of the physical science is astronomy, and its early history is more important than that of any other. Indeed, it may be said that the state of scientific culture among the early peoples was little more than the practical observations of astronomy. This science had its beginning among the Chaldeans and the Chinese. These ancient observers of the heavens were able to predict eclipses with considerable accuracy, were acquainted with certain forms of the calendar. Among the Chinese are extant authentic observation of eclipses, comets, etc., extending back for 1,000 years before our era. In Egypt, among the Greeks, and among the most ancient races, the observations of the heavens and the study of the stars constituted the scientific culture of the most conspicuous intellects. In the 2nd century before our era, Ptolemy, from superficial observation of the apparent movements of heavenly bodies, invented the epicyclic system of the universe, making the sun and planets revolve in circles whose centers are themselves in motion upon other circles, the Earth being the center of the system. All the observations and speculations under this hypothesis contributed nothing to the development of a science of astronomy, hardly increasing the material out of which such a science could be constructed. It is with Copernicus that astronomy is born into the family of sciences as the eldest child. For centuries, the general notion of the system, which probably originated with Pythagoras, was altogether overlooked. owing to the general acceptance of the Ptolemaic astronomy. The claim of Copernicus to the glory of being the father of the science rests upon the fact that, after centuries had passed, he brought to light this ancient conception and greatly increased the probability of its truth by his calculations and arguments. Here we meet the fresh beginning of another branch of science, and one that was indispensable to the further development of astronomy. Physical philosophy had its origin, too, in a distant past, and many illustrious names of thoughtful Greeks are associated with its early attempts to solve the riddle of the universe. Pythagoras is placed at the origin of the Italic school, but history records no systematic development of his teachings. The Ionic school, however, which is referred back to Thales, one of the ancient wise men of Greece, had a progressive development culminating in the physical treatise of Aristotle. But with this culmination, its progress closed and left the human mind to remain stationary on all such subjects for nearly 2,000 years. The physical philosophy of these two schools is especially deserving of our study, as exhibiting the character and fortunes of the most memorable attempt at universal knowledge that has ever been made. It is highly instructive to trace the principles of this undertaking, for the course pursued was certainly one of the most natural and tempting that could be imagined. The essay was made by a nation unequaled in fine mental endowments at a period of its greatest activity and vigor, and yet it must be allowed to have been unsuccessful. Footnote: see Whewell, History of the Inductive Sciences, Volume 1, page 56. End of footnote. So physical science rested until the times of Copernicus and Galileo and Kepler and Newton, when joining hands with astronomy, an advance was made which has ever since been going on with increasing velocity to the present day. The whole conception of the physical world has been revolutionized in these modern times. A heliocentric solar system has taken the place of the geocentric. The stars have been resolved into suns like our own, and all the heavenly bodies are seen to be moving in their majestic orbits around remote centers. The laws of motion, as discovered by Galileo and Kepler, and the law of gravitation, rule throughout the visible universe, and all the motions of the heavenly bodies are capable of being set forth in mathematical formulae. After the long period of inactivity in physics and astronomy had come to an end, the human mind was again thoroughly aroused, and discoveries crowded rapidly upon one another. On every side, tempting fields of investigation and speculation opened, offering richer promises to laborers. The invention of the telescope made possible new views of the heavens. The moon's surface was scrutinized. The phases of the planet Venus were seen. The discovery was made of the rings of Saturn and satellites of Jupiter and spots on the sun. Then Napier gave to mathematicians an incalculable aid to their efforts by the invention of logarithms. A twofold progress resulted from these inventions: a rapid ingathering of a vast harvest of facts, and a widespread and most fruitful mathematical treatment of these facts of observation. The science of mechanics became an attractive field of inquiry and investigation, resulting in the discovery and formulation of the laws of motion. Applying these mechanical principles to the motions of the planets, Galileo and Kepler determined their elliptical orbits, their periods of revolution, etc. Then came Newton's great work, the Principia, which may be primarily considered a work on mechanics, until a science of dynamics was discovered and formulated, until the laws of earthly motion were divulged. The most profound and keenest intellects groped aimlessly in their pursuit of the laws of heavenly movements. Bacon and Kepler failed because there was wanting in their day a true theory of motion, because there was not a science of mechanics. Bacon himself bears witness to the futility of the efforts of the great minds of his time in constructing a true science of astronomy. This great father of the inductive method declares that while astronomy up to that time had for her business to inquire into the principles or rules of the heavenly motions, and philosophy into their causes, they both had so far worked without due appreciation of their respective tasks. Philosophy ignored facts, while astronomy claimed assent to her mathematical hypotheses, which ought to be considered as mere steps and symbols of calculation. He goes on to say, since, therefore, each science has hitherto been a slight and ill-constructed thing, we must assuredly take a firmer stand. Our ground being that these two subjects, which, on account of the narrowness of man's views and the traditions of professors, have been so long dissevered, are in fact one and the same thing, and compose one body of science. The guesses and speculations of that very great and illustrious mathematician Kepler, to whom we are indeed more greatly indebted than to Copernicus himself for the establishment of the so-called Copernican theory, are stated in formula and phrases that today seem puerile and amusing. Thus he introduces a chapter of his work on the planet Mars. Quote, a physical speculation in which it is demonstrated that the vehicle of that virtue which urges the planets circulates through the spaces of the universe after the manner of a river or whirlpool moving quicker than the planets. End quotes. He speaks of the moving force, the magnetic nature, the immaterial virtue of the sun, which cannot be said to convey any distinct conception. Kepler's physical theory, as applied to astronomy, was in fact the doctrine of vortices around the central bodies, and these vortices constantly whirling around these central bodies carry the moon and planets as the whirlpool carries straws. He further asserts that these vortices are immaterial species. All these are mere conjectures, not founded upon ascertained facts, nor attempted to be verified by observation of terrestrial movements. Some score of years later, Descartes, the father of modern philosophy, himself a master in mathematics, set forth a similar theory of vortices incorporated in his Principia Philosophiae. He imagines three kinds of matter, the properties of which are equally imaginary. The first kind of matter makes luminous bodies. The second, the transparent substance of the skies. The third is the material of the opaque bodies, the earth, planets, and comets. Then he supposes that the motions of these parts take the form of vortices. By this means, the first kind of matter, which produces the luminous bodies like the sun, is collected to the center of each vortex, while the second and subtle matter surrounds it and by its centrifugal effort constitutes light, and the planets, composed of the third kind of matter, are carried round the sun by the motion of his vortex. For a considerable period, this was the accepted theory of matter and of celestial mechanics. Many eminent philosophers and mathematicians readily adopted it, doubtless upon the reputation of its illustrious author, who was a man of high claims in every department of speculation and, as a mathematician, a genuine inventor of great eminence. Of course, this theory did not long survive in the rapid progress of discovery that had already begun. It had no value whatever in the advancement of science, and is here alluded to only as an instance of theorizing without regard to discovered and verified facts, and without following the inductive method of observation and experiment. Leibniz, though not a follower of Descartes, had said that the Cartesian philosophy was the antechamber of truth, a compliment scarcely deserved. For, as Whewell pleasantly remarked, those who first came into the presence of the truth herself were those who had never entered this imagined antechamber, and those who were first in the antechamber were the last in penetrating farther. Playfair extends to Descartes, as a natural scientist, the doubtful credit of having rendered Newton a service by having exhausted one of the most tempting forms of error. In England, before the days of Newton, there were many men of preeminent ability in mathematics who discerned the true character of the problem of curvilinear motion. Conspicuous among these was Hooke, of Christ Church, Oxford, who distinctly stated that the planets would move in straight lines if they were not deflected by central forces, and that the central attractive power increases in approaching the center in certain degrees dependent on the distance. Here we have an attempt at a solution of far greater value than all the speculations of all former philosophers who disregarded the careful observation of the laws of terrestrial mechanics. Reaching the work of Sir Isaac Newton, we are in the presence of the greatest scientific discovery ever made. The order and movements of the heavenly bodies stand forth in all their perfection and beauty. The guesses of the past were verified or refuted. The observations were mathematically expressed and justified, and the unity and harmonious order of the universe were made clear as the day. The ancient speculations of astronomers by the effectual aid of physics and mathematics were reduced to one all-embracing cosmic generalization. The science of astronomy was created, and the whole physical universe was presented in a new and comprehensive aspect. The known solar system at that time consisted of Sun, Moon, Earth, and 5 planets visible to the naked eye. Through all the centuries of the past, since the days when the Chaldean shepherds studied the starry heavens, no discoverer had observed another member of the solar system. It was not until a century had passed after publication of Newton's Principia that Herschel's telescope won the first great triumph in the discovery of Uranus. After the general acceptance of the Newtonian theory, the glorious labors of Lagrange, Laplace, and other mathematicians were necessary to remove many remaining difficulties connected with planetary perturbations and the inequalities in the moon's motion. Their illustrious labors bore their full fruitage a half-century later, when the discovery of Neptune by pure mathematical reason from the perturbations of Uranus furnished for this theory the most triumphant confirmation and demonstration known in the whole history of science. The sidereal heavens were not studied at this time beyond the cataloging of such stars and nebula as could be seen with the telescopes then at command. A century and a half had passed after Newton's great generalization before it was sought to bring the stars within it. Until less than 100 years ago, the ascertaining of the distance of a star had not been successfully attempted. So late as 1836, Auguste Comte declared such a feat to be possible, and that the Newtonian theory could never be proved to extend throughout the stellar regions of the universe. 3 years later, Bessel measured the distance of 61 Cygni, and the subsequent study of the movements of double and multiple stars soon established the fact that the law of gravitation embraces the whole sidereal heavens. The development of another science, that of chemistry, opened the way for marvelous advance in astronomy. In 1774, Dr. Priestley found that by heating red precipitate, an incombustible gas was obtained. This gas, the commonest element in nature, constituting 1/5 of the atmosphere in volume, 8/9 of the ocean by weight, and 1/2 the Earth's solid crust, was oxygen. This was the period of the emergence of chemistry from the unfruitful alchemy of a distant past. As the science of chemistry advanced, and the 70-odd chemical elements were discovered, and all the constituent elements of Earth and the atmospheric ingredients were ascertained, the mind of man sought to know whether or not all the shining orbs of heavens were alike composed. And here opens before us a chapter in the science of astronomy which even the boldest speculation of half a century ago would have dismissed as a baseless dream. The invention of the spectroscope and the discovery of spectrum analysis have supplied the data for a celestial chemistry. Quote, hydrogen is detected in the far-off dog star and the nebula of Orion, sodium, potassium, calcium, and iron in the Sun, demonstrating the gaseous character of the nebula and revealing chemical elements hitherto unknown, such as helium, a mineral first detected in the Sun and afterward found in Norway. End of quote. Footnote: John Fiske, A Century of Science, page 7. End of footnote. More wonderful still is the fact that spectrum analysis enables us, through a slight shifting in the wavelengths of the light it emits, to measure the motion of a star. We can by this means detect the approach or recession of a distant heavenly body. The spectrum of the star Algol tells a most interesting story. Algol, a sun of the magnitude of our sun, has a dark body revolving about it nearly its own size, and itself is in revolution round another dark body. The spectrum reveals the presence and gravitative effects of the two invisible stars, and also explains, as due to irregular eclipses, its long observed variations in brilliancy. Thus again is witness borne to the uniformity and unity of the physical world. Not only are the laws of motion on Earth identical with those of the whole material universe, but the same chemistry applies to celestial as to terrestrial phenomena. The questions ever present in the human mind: whence came this wonderful world? Was it created by divine act? Was it always as now? Has it come to its present state and condition by gradual development and evolution? Have led to many attempts to construct a cosmogony. Some of these guesses of the ancients we shall hereafter consider. In modern times, the nebular hypothesis of Laplace was the first fruitful effort to apply scientific facts and methods to the solution of these cosmic problems. The author of this theory, one of the very first mathematicians of all time, did not claim for it the authority of a demonstration, but the most advanced physicists and astronomers of today assume its general correctness and accept the same as a valid working hypothesis. By this hypothesis, we have the physical world originating in an infinitely diffuse nebula possessing a rotary motion. Intense heat is generated by physical or mechanical forces. Portions cooling give off their heat and contract, leaving rings behind, which themselves break up into globes rotating on axes and revolving around centers of gravitation. So the innumerable stars that fleck the immensities of space came into their present state, and their several systems were thus developed. Gazing at the heavens through the telescope and studying the composition and states of development of celestial bodies by means of the spectroscope and the sensitive photograph plate applied to the telescope, we see suns and solar systems in every stage of evolution, from the nebula entering upon its cosmic being to bodies like the moon passing down to darkness, decay, and death. Though it may be that this hypothesis has not yet obtained the formal credentials of science entitling it to a place among its verities, it seems to withstand successfully all criticism, and to maintain an honorable position among the most probable theories of the evolution of the physical process. It has been stated by its great author in correct mathematical formula, and observation affords us more and more satisfactory evidence of its truth. Sir Norman Lockyer has given to the world a cosmogonic theory quite different from the nebular hypothesis of Kant and Laplace, which he calls the meteoritic hypothesis. It assumes that the stars have been made up by the combining together of masses of meteors, space being supposed to contain numberless swarms of these little bodies. It is altogether probable that these theories taken together give the full account of the development of the sidereal and planetary systems. The meteoritic upbuilding may have been preliminary to the nebulous state. The forcible gathering together of the meteorites may have caused the intense heat by which the mass was vaporized and transformed into the nebulous state. Then begins the wondrous tale of contraction, the throwing off of rings, and cooling and contracting into solid spheres, supplied with air and water, fitted for the abode of life. These theories carry us back to a beginning of the physical process. I use the words a beginning with intent, for there is now arising a school of scientific philosophers who insist that the whole process is made up of series of evolutions and devolutions ad infinitum. It is inconceivable, however, that there should be no actual beginning of the entire process unless we shall accept some such hypothesis as that which this treatise is intended to propose and support. That the phenomena of the physical process are all the products of the energy of an infinite, eternal, infinitely energetic, psychical universe, upon which the material world depends for its being and innumerable activities. An evolving world passing from a universal homogeneity to an infinite heterogeneity must increasingly manifest the presence of manifold forms of energy and demands a source of its ever-increasing supply of active or kinetic power. If the physical process be only a phase of universal, infinite, and eternal activity, if this material world rests upon and is interpreted by the immaterial, infinite, and infinitely energetic universe, then we need not inquire as to its beginnings, for every activity is but an expression of an ever and everywhere present energy. This hypothesis sets aside at least one of those transcendental and insoluble world enigmas, which, according to Ernst Haeckel, Emile Dubois Raymond stated some years since before the Berlin Academy of Sciences, namely, the origin of motion. Thus briefly have we traced the history of the development of the science of astronomy, which is no less than the history of the physical process until the organic world is reached. From our long flight out into the immensities of space, from our journey amid the wonderful revelations of astronomy, we descend to Earth and resume the study of the record of man's pursuit of truth. The development of the science of astronomy has resulted in a vast enlargement of the mental horizon with reference to space. But the 19th century has witnessed also a notable enlargement with reference to time. The 18th century closed before any fruitful endeavor was made to study inductively the Earth's history as written through the centuries in the stony volume of the Earth's crust. Indeed, during the early years of the 19th century, men of intelligence and education could be found, who with unshaken confidence maintained that fossils had been created dead and petrified and placed by the hands of omnipotence beneath the rock-ribbed surface of the earth. It was not until 1830 that the science of geology won its first and memorable triumph with Sir Charles Lyell. Geologists before his time had been led to conclude that the general aspect of the Earth's surface with which we are familiar is not its primitive and permanent aspect, but that there has been a succession of ages in which the relations of land and water, of mountains and plains, have varied to a very considerable extent. In order to account for such changes, geologists were disposed to imagine violent catastrophes brought about by strange agencies in some vague and unaccountable way, utterly unlike those forces now at work in the visible and familiar order of nature. But Lyell proved that the very same processes now going on all about us are altogether sufficient to account for the changes in the inorganic world which distinguish one period of the Earth's development from another. It was then that attention was first drawn to the important element of time. These changes were slowly effected. Through long periods, unobtrusive and apparently inefficient agency were at work, at length bringing forth by cumulative action marvelous results. Astronomy, as we have seen, steadily advanced toward the proof that in the abysses of space, the physical forces are identical with those operating on Earth. So geology, carrying us back through long periods of time, show us that the forces now at work are the same as those which have brought forth all the geological changes since the remotest past. The philosophic significance and purport of all this in geology are the same as proclaimed by the progress of astronomy. Of course, in the very earliest stages of the development of the Earth's crust, the temperature was excessively high, and so phenomena were manifested no longer to be witnessed on the Earth's surface. But in other parts of the solar system, as for instance on the great planet Jupiter, the same forces are at work producing the same results as in those far-off ages in the history of the Earth. Quote, "Ever since our Earth cooled to a point at which its solid crust acquired stability, since the earliest mollusks and vertebrates began to swim in the seas, and worms to crawl in the damp ground, if at almost any time we could have come here on a visit, we should doubtless have found things going on at measured pace very much as at present. Here and there earthquake and avalanche, fire and flood, but generally rain falling, sun shining, quickening, all as quiet and peaceful as a daisied field in June, without the slightest visible presage of continuous series of minute secular changes that were gradually to transform a Carboniferous world into what was by and by to be a Jurassic world, and that again into what was after a while to be an Eocene world, and so on, until the aspect of the world that we know today should noiselessly steal upon us." End of quote. Footnote. John Fiske, A Century of Science, page 12. End of footnote. These conclusions of Sir Charles Lyell exerted an enormous influence upon men's habits of thought. The orderly ongoing of nature, the quiet working out of an advancing progress by the familiar forces ever operative, led naturally to a dynamical rather than a statical conception of the physical world. In the course of our brief review of the history of astronomy, allusion has been made to celestial chemistry and the marvelous results attained by spectrum analysis. These achievements would have been impossible without the previous development of the science of chemistry. This science may be said to have been born and reared in the 19th century. It may be positively asserted that the ancients, the Egyptians, the Greeks, and the Romans never made the smallest contribution to the science of chemistry. Indeed, what could be expected of an age when its greatest thinker and scientist, Aristotle, did not hesitate to say that a vessel filled with ashes will hold as much water as if empty? When Priestley discovered oxygen in 1774, there was no science of chemistry, and men of that day did not know what took place when a log of wood was burned on the hearth. Stahl, a contemporary of Newton, invented, or rather imagined, the doctrine of phlogiston to account for combustion. This doctrine supposed that all combustible substances contained a common element, a pre-principle called phlogiston, which escapes in burning. This fire principle was regarded as having no weight, so as to avoid the conclusion following upon the discovery of the fact that there was no loss of weight in the process of combustion. The discovery of oxygen and the further study of its properties revealed the fact that whatever may escape during combustion, oxygen is always combined with the burning substance. Then Lavoisier came with his balance and proved that when a thing burns, it unites with oxygen, and that the resulting product is equal in weight to the substance burnt, plus the oxygen drawn from the atmosphere. It did not take long for the awakened mind of man to step from this discovery to the verification of the truth that in all chemical changes nothing is lost, nothing is gained, and to formulate the fundamental law of the material world, the indestructibility of matter. Not only has the science of chemistry discovered the 70 or more elemental substances, invented methods of innumerable transformations and combinations, and formulated a system for the investigation of substances of inorganic nature, but it has entered the organic world and investigated the chemical processes in the living organism. Chemists have actually succeeded in building up from their elements several thousand compounds found ready-made only in the organisms of plants and animals, doing away with the idea that life force is indispensable to the formation of these compounds. As yet, the most advanced chemists have been unable to produce protoplasm, the physical basis of life. The physical basis of life. But there are many daring investigators who are confident not only of producing this ultimate compound, but of bringing forth a conscious, thinking, willing, and loving being artificially in their laboratories. Here we step over the borderline of another and still newer branch of science, biology. To many who are not too conservative, this science, as set forth by its more radical students, seems to venture beyond reason in its claims as to the possible limits of its discoveries. The writer of the article on biology in the International Encyclopedia sets forth the mechanical interpretation of biological facts in the following words. Quote, "Future discovery may prove that all the facts of biology, including those of consciousness, reason, volition, and moral obligation, are, in ultimate analysis, movements of matter in accordance with the mechanical principles which hold good throughout the inorganic universe." End quote. Although this young science has made remarkable progress in discovery and has already reaped a large harvest of facts, these claims sound like the groundless vauntings of youth or the baseless expectations of young manhood. It seems as if the actual discovery of spontaneous generation were now imminent. From various laboratories has come the declaration of reputable chemists and men of science that the discovery has indeed been made. It is now reported that Professor Burke, who for the past 6 years has been conducting experiments in the Cavendish Laboratory at Cambridge University, has, by putting together in a test tube radium and sterilized bullion, produced cultures presenting many appearances of vitality, such as growth and subdivision. This discovery has caused much alarm and concern on the part of the believers in special creations, who also believe that every new life is fresh from the hands of God. Those, too, who have felt themselves compelled to give a general assent to the doctrine of evolution have thought to find place for divine interposition, if nowhere else, at least at the impassable chasm between the organic and the inorganic. This being successfully bridged, God is excluded from the whole process of physical development, which seems, therefore, to go on its way automatically and to be self-explanatory. If the physical world be the eternal and infinite universe, then is there no place for God? On the generally accepted hypothesis of a Deus ex machina, or even that of an immanent deity, there can be no ground for a theist to stand upon if life can be chemically or mechanically produced. We cannot admit the unbroken continuity of the physical process and still allow place for the divine agency. If the entire process is accounted for in terms of physical energy, then is there no need of a creator or sustainer of the world? Nevertheless, if all this and more were scientifically established, if the rational and willing being should come to be manufactured to order without waiting for the slow and painful process of nature, the hypothesis set forth in the following pages would not be unfavorably affected. Suppose the chemist shall succeed in producing protoplasm, and further suppose, upon being chemically produced, it should immediately spring into life. That would not prove life to be the product of the chemical process. In order to establish such a conclusion, it would be necessary to find the equivalence of the life force in mechanical terms. When, a generation ago, leading men of science were endeavoring to establish the spontaneous generation of life, the most careful observations and experiments were made. The liquid in which these new germs were expected to manifest themselves was boiled, so as to destroy all existing life, and the same was hermetically sealed, so as to prevent any other germs from the atmosphere coming into it. Under these conditions, life did not appear. It was thereupon concluded that life can come only from life. So if, as we have supposed above, the physical basis of life should be artificially produced with all the essential chemical properties, and life should be manifested therein, then it would be required of our biologist to show that there is no force in the universe, other than that he is able to investigate, which always manifests itself under such conditions. Living protoplasm and dead protoplasm, if not essentially different, differ wholly in function and properties. The one has powers of natural growth and development, the other is in a state of disintegration. All the processes of living organism, so far as they can be investigated by scientific methods and appliances, are physical or chemical. But the ultimate forces and essential conditions are beyond the sphere of scientific investigation. Science can discover the law and develop the mathematical formula of the force of gravitation, but what gravitation is and how one body attracts another body at a distance, science has no well-grounded hope of ever finding out. With all the wonderful discoveries of chemistry peering into the most mysterious secrets of nature's penetralia, that science now confesses utter ignorance concerning affinity, the force that holds in combination the constituent elements of chemical compounds and causes the reaction taking place between material substances. The imagination has had its part in offering explanations, if not solutions, of this problem. Borelli and Lemery, followed by 1,000 less distinguished, imagined that the atoms or ultimate particles of matter were supplied with minute hooks, the shape of which determined the capacity of a particle for combining with other particles. Bergman, Berthollet, and others thought chemical affinity might be identical with the energy of gravitation. Berzelius, who played so large a part in the early development of the science of chemistry, than whose name there is none more distinguished on the roll of honor of that science, sought to explain all chemical phenomena on the hypothesis that chemical combination was caused by the mutual attraction of electrically different substances. All these hypotheses, however, do not go any further toward an explanation of the transformations and combinations of substances than did the ancient idea that different atoms combined, or substances were transformed because of the love or hate they felt for each other. This long ago rejected product of man's youthful imagination seems to be adopted and employed by Haeckel in his last successful appeal for popular favor, the riddle of the universe. So stand all the subordinate branches of biology, zoology, embryology, and physiology toward the question of what life is, and the ineffectual efforts to show vitality to be a form of physical energy by its transformation into some mechanical equivalent capable of being expressed in foot-pounds ought to warn such scientists against the waste of most valuable time and effort in seeking that which by their method must ever remain undiscoverable. Other biologists ignore or deny the existence of any such agency or energy. More reason, certainly, would the chemist have to deny chemical affinity, or the physicist to deny the force of gravitation. Treat it as we may, there is a vast and inexplicable difference between the organic world and the organic, between that which is living and that which is not alive. The physicist, too, in his present diligent search into the structure of matter, going down into the deepest region of speculation, expresses no hope of discovering the ultimate explanation. Professor Lodge, in Modern Views on Matter, footnote, Sir Lodge, Modern Views, page 13, end of footnote, which may be regarded as the latest authoritative declaration of the most recent findings of science in this field, says, quote, "This, when established, will be a unification of matter such as has throughout the ages been sought. It goes further than had been hoped, for the substratum is not an unknown and hypothetical proton, but the familiar electrical charge. Nevertheless, of course, this is no ultimate explanation. The question remains, what then is an electrical charge? What is the internal structure and constitution of an electron? Wherein lies the difference between positive and negative electricity? And what is their relation to the ether of space?" End of quote. These are legitimate questions, the answer to which may be discovered in the future, but beyond is the impenetrable mystery. What is electricity? One marked and suggestive characteristic of all the most recent and most promising investigations in the nature of the ultimate atom is the tendency toward reducing all material existence to a dynamic origin. From the vortex ring of Helmholtz and Thomson to the hypothesis stated in Sir Oliver Lodge's lecture from which we have just quoted, a material basis of the atom is more and more discredited. The time seems not far distant when Haeckel's hope of reducing his double law of substance to a unity will be realized, but not in accordance with his expectation. He would unify the law by making a compound statement of it as the law of the persistence of matter and force. But the empirical results now point to reducing matter to an expression of force. Quote, "It becomes a reasonable hypothesis to surmise that the whole of the atom may be built up of positive and negative electrons interleaved together, and of nothing else. It is possible, but to me very unlikely, that the electron, as we know it, contains a material nucleus in addition to its charge. So in that case it need not be so concentrated, because a portion of its mass would be otherwise accounted for. I say accounted for, but it would be rather true to say unaccounted for. For the mass which is explicable electrically is to a considerable extent understood, but the mass which is merely material, whatever that may mean, is not understood at all. We know more about electricity than about matter, and the way in which electrical inertia is accounted for electromagnetically and localized in the ether immediately surrounding the nucleus of charge is comparatively clear and distinct. There may possibly be two different kinds of inertia which exactly simulate each other, the one material and the other electrical, and those who hold this as a reasonable possibility are careful to speak of electrons as corpuscles, meaning charged particles of matter of extremely small size, much smaller than an atom, consisting of a definite electrical charge and an unknown material nucleus, which nucleus, as they recognize but have not yet finally proved, may quite possibly be zero." End quote. Footnote, Lodge, Modern Views, page 13. End footnote. Further unification of the origin or source of the energy, as well as the material of the physical process, is promised us by the researches of Larmor, Rutherford, and others. It is becoming more probable that there is no other source of light or any other form of radiation possible except a change in the motion of electrons. It is known, says Lodge, that the violent acceleration or retardation of electrons when they encounter an obstacle is responsible for the excitation of Roentgen rays. All light and all the Hertz waves or pulses employed in wireless telegraphy are due to electric acceleration, and the greater the rate of change of velocity, the more violent is the radiation emitted. We seem thus to be getting back to the beginning of things. Another wonder meets us as we follow the guidance of certain of these most successful investigators. The quest of the alchemists of the Middle Ages was the process by which one form of matter could be changed into another. In the laboratories of Professor Rutherford and of Mr. Soddy, these transmutations have been observed by these careful experimenters. In radioactivity, the radioactive substance throws off atoms of matter, leaving behind in its pores another substance, which has been examined even more completely than the projected portion. This remaining substance is volatile. It slowly diffuses away and behaves like a gas. Many other qualities have been discovered. It is also radioactive, throwing away part of itself and leaving yet another residuum, itself radioactive. One of these residues thus left seems to cast off electrons simply instead of atoms of matter. All radioactive substances are not to be supposed to act precisely alike. The emanation from one may lose its activity rapidly and give rise to another substance retaining its power for some time. That thrown off by another element may last some time and generate a substance whose activity rapidly decays. The transmutation of elements vaguely deducible by skillful observers from spectroscopic details of solar and stellar appearances, the evolution of matter likewise caught sight of by chemists of genius, these were speculations but yesterday. Now, in radioactive matter, the process is seen to be going on before our very eyes. Through these daring yet warranted investigations into the ultimate structure of matter, we are brought to an atom which exists without a material basis, showing us matter as ultimately a manifestation of energy. When we shall have reached this discovery, we shall have arrived at the uttermost boundaries of the physical process and the limits of possible physical investigation. Another branch of science of biology, histology, or the science of cells, has opened to us a most interesting and fruitful field of research. In 1802, Bicot, a French physician, attempted to determine, with the aid of the microscope, the ultimate constituents of the tissues and organs of the body, but without any valuable results. It remained for Matthias Kleiden to discover that the common element in all the tissues of vegetable organism is the cell. And very soon thereafter, Theodor Schwann proved the same to be true of all animal tissues, thus establishing the ultimate basis of all living organisms. Kolliker and Virchow, to adopt the language of Haeckel, proved that in man and in all other animals, every tissue is made up of the same microscopic particles, the cells. And these elementary organisms are the real self-active citizens which, in combinations of millions, constitute the cellular state, our body. Then we come upon another unifying principle as follows. All these cells spring by a process of subdivision from one simple cell, the impregnated ovum. Not only when we trace the course of the life history of an individual organism back to its beginning in the impregnated ovum do we come finally to a primitive cell, but when we follow the process of development of the human organism from the primordial germ, the moneron, we start with the ultimate organism from which all forms of life on earth may be said to spring. This simple cytod, the whole body of which consists of soft, structureless plasm, is more elemental than any cell in any higher organism, for it does not so much as possess even a nucleus, which belongs to every true cell, and is therefore absolutely without organs. Yet this primitive globule of protoplasm is, in a sense, an organized intelligence. Dr. Gates, a recognized authority in histology, says, unicellular organisms possess all the different forms of activity to be found in the higher animals. Binet, an eminent biologist who has made a most exhaustive study of the psychic life of microorganisms, remarks that the complexity of the psychic life of these ultimate living units is shown by the power of selection exercised either in the search for food or in the maneuvers attending conjugation. The act of selection, he further says, is a capital phenomenon. As Romanes has indeed observed, the power of choice may be regarded as the criterion of psychical faculties. These primitive forms of life manifest in the simplest way the phenomena of the psychic life of higher organisms, even of man. Romanes, in his great work, Mental Evolution in Animals, distinguishes clearly between reflex action and instinctive action. The former, he explains, is non-mental, neuromuscular adaptation to appropriate stimuli, but instinctive action is something more than this. There is in it the element of mind. Curious evidences of mental operation are observed in the conduct of the Flugia ampulla, which inhabits a shell formed of particles of sand. This little rhizopod emits long pseudopodia, which search at the bottom of the water for the materials necessary to construct a new case for the filial organism to which it gives birth by division. The pseudopod, having touched a grain of sand, is seen to draw the particle into the body of the tiny animal. Verworn, whose recent investigations have greatly illuminated this most interesting subject, in making certain experiments, placed about the animal small fragments of colored glass instead of sand, and soon noticed a heap of these fragments on the bottom of the shell. He then observed a globule of protoplasm issue from the shell. This was the offspring. Thereupon, the bits of glass were ejected from the shell and enveloped the body of the new individual in a sheath similar to that encasing the mother. These bits of glass, held loosely together at first, are soon firmly cemented by a substance secreted by the body of the parent. Binet, commenting upon this experiment, makes certain very important observations. He says, quote, "Two facts are to be remarked in this experiment. First, the act whereby the difflugia collects the materials for providing the young individual with a case is an act of pre-adaptation to an end not present, but remote. This act, therefore, has all the marks of an instinct. Further, the instinct of these little beings exhibits exact precision. for they not only know how to distinguish at the bottom of the water the materials available for their purpose, but they in every instance take only the quantity of material necessary to enable the young individuals to acquire each a well-built case. There is never an excess. It is interesting to note that this elemental primitive creature does not act differently from animals possessing more highly complicated organizations and endowed with differentiated nervous systems, as for instance the larvae of phryganids, which form their sheath from shells, grains of sand, or minute slivers. End of quote. Mind is manifest, as we see, from the very dawn of animal life, and everywhere exhibits the very same marks and characteristics. Life and intelligence, in some degree, are invariable concomitants in this material world, just as every beam of sunlight, when analyzed by the spectroscope, is seen to be composed of the actinic as well as the light and heat rays. The ever-increasing manifestation of intelligence through instinct to reason, self-consciousness, and sporadic instances of genius has always been concomitant with the evolution of the organism. The more complex and highly developed mental organism exhibiting the higher powers of intellect. So remains, and after him countless investigators of less distinction and genius have held that if the doctrine of organic evolution is accepted, it carries with it, as a necessary corollary, the doctrine of mental evolution, at all events as far as the brute creation is concerned. There seems to be some confusion of thought in this statement, and an unwarranted extension of inference from the verified facts of science. All that can be said in the name and under the warrant of science is that there has been an evolution of the material organ of mind, and that through this more and more complex developed organ there have been manifested higher and higher forms of mental activity. There is no evidence whatever of an evolution of mind. We have no scientific method by which we can determine more or less of mentality in a scientific sense. The fact of evidence of higher manifestations of mind does not prove that these higher manifestations are not altogether accounted for by the complexity in structure and constitution of the physical organ of mind, the brain. We have seen that which distinguishes instinct from mere reflex action is mentality. This mentality is not physically accounted for. It cannot be investigated by scientific appliances and methods. It is not transformable into any form of physical energy. It eludes all attempts to discover its modes of activity. We know experimentally nothing at all about it. This being true, how can we say there has been an evolution of mind concomitant with that of the physical organism? Given an intelligent or psychical universe, the forms of whose energy are crowding to manifest themselves in what we call the material world, then, whenever and wherever the organic evolution brings forth a sufficiently complex organism, the higher and higher forms of mind activity are observed. We are informed, and the statement is based upon the authority of Darwin and Romanes, that both primary and secondary instincts are hereditable. But even supported by such authority and that of almost every great biologist, we humbly, but most positively, decline to accept it as true. There is not the slightest evidence of a scientific character of any inheritance transmitted from parent to offspring, except that which is physical. The fact that the instinctive intelligence of the moneron is identical in nature with that of man does not so much as raise a presumption that the mind of man is an evolution from the rudimentary intelligence of the primordial germ. All that can be proved is the development of the higher organism from the primal and unorganized globule of protoplasm. There are but two possible interpretations of the facts of evolution as science warrants them to us. First, the increasing intelligence being concurrent and coincident with the growth and development of the organ of mind is the essential product of the organism. This theory has been accepted by materialists, but it is at least unscientific, for it asserts that a material organ, whose processes can all be experimentally accounted for, can bring forth an immaterial product altogether inscrutable and beyond the reach of our methods of investigation. The second supposition is that cosmic forces of a higher order than those of the physical process manifest their activities whenever the degree of development of the organism is reached at which these activities can utter themselves. These forces of the unseen universe, ever pressing forward to manifest their activities in the material world, can find expression only under certain appropriate and adequate physical conditions. The sunbeam, as we have seen, is composed of the heat, light, and actinic rays. The heat wave striking the body produces the sensation of heat. The light wave beating upon the sensitive organ of sight produces vision. But we possess no organ of sense capable of responding to the subtle touch of the chemical wave. In the green leaf of the tree, this imperceptible ray decomposes the carbonic acid of the atmosphere and supplies nourishment to the vegetable world. Further to illustrate from the familiar phenomena of the material world, the dynamo in rapid motion in the powerhouse, as we say, generates electricity. This electricity is conducted along wires until at length a part of the current, being arrested in its course, is transformed into light. Or again, traversing the wire, the current passes into a motor and is transformed into motion and motive power. This current would forever exist unknown and unobserved unless conditions favorable to its manifestation were created. Nature, indeed, is but the manifestation under favorable conditions of the invisible forces of the universe. The germination of the seed furnishes another apt illustration of the theory we are supporting. The life principle, if such exists, cannot be supposed to be imprisoned in the undeveloped seed and, under certain favoring conditions of moisture and temperature, to liberate itself and pass through innumerable metamorphoses of being. If the seed by any means has lost its vitality, then moisture and heat will but hasten its decay and disintegration. That which, as we say, has destroyed the life of the grain of wheat has, in truth, only unfavorably affected the organism, so that the unseen energy we call life cannot manifest itself therein. This is a more reasonable hypothesis. All the phenomena are accounted for within the physical process, so far as science enables us to study them. In recent years, attempts, not encouragingly successful, have been made to reduce psychology to a science and to study the phenomena of the soul in accordance with scientific methods. Professor James introduces his treatise on psychology with the statement that the subject is to be treated as a natural science. After traversing the whole range of the experimental psychology, he concludes with these significant words, quote, "When, then, we talk of psychology as a natural science, we must not assume that that means a kind of psychology that stands at last on solid ground. It means just the reverse. It means a psychology particularly fragile, and into which the waters of metaphysics leak at every point. A psychology all of whose elementary assumptions and data must be considered in wider connections and translated into other terms. It is, in short, a phrase of diffidence and not of arrogance, and it is indeed strange to hear people talk triumphantly of the new psychology and write histories of psychology when into the real elements and forces which the word covers not the first glimpse of clear insight exists. This is no science. It is only the hope of a science. The matter of science is with us." End of quote. Footnote, Professor James, Psychology, pages 467 and 468. End of footnote. This confession of failure to construct a science of psychology as embracing and accounting for all the facts of psychological experience ought to satisfy us that, in striving to make psychology a branch of natural science, we are attempting to employ methods of observation wholly inapt and inadequate to the matter to be investigated. It is like striving to see with the ears or to hear with the sense of touch. Of course, that which the so-called science of psychology does find itself competent to treat of, it's already covered by the pure sciences of physiology, chemistry, and physics. When the psychologist comes to talk about states of consciousness, me and I, or thoughts without a thinker, or the knower to whom the knowledge belongs, scientifically considered, he merely talks in a jargon without any meaning. Professor James further asserts, quote, "Whenever I try to become sensible of my thinking activity as such, what I catch is some bodily fact, an impression coming from my brow or head or throat or nose." End quote. In spite of the common sense of mankind, every careful observer must reach the same conclusion, and thus admit that all we know of such phenomena as objects of sense perception, which phenomena, as such, are alone capable of scientific investigation, are the bodily facts, the physical, chemical, and neurological activities. The diagrams, which are produced by the experimental apparatus in psychological laboratories, reveal 3 lines, we are informed. One is set down as due to respiration, the second as due to blood circulation, the third remains uninterpreted, but is certainly due to nerve activities about which, as yet, we have gained very little positive information. There is in these diagrams no suggestion of any other than physical activities, and we are driven to accept one of 2 conclusions. Either there is in psychological phenomena nothing beyond or besides the physical element or activity, or the real facts of psychology are postulates beyond the limits of scientific investigation. To conclude this chapter with the words of Professor James, quote, "It seems as if consciousness, as an inner activity, were rather a postulate than a sensibly given fact. The postulate, namely, of a knower as correlative to all this known. The present psychology is in the condition of physics before Galileo and the laws of motion, of chemistry before Lavoisier and the notion that mass is preserved in all reactions. The Galileo and the Lavoisier of psychology will be famous men, indeed, when they come, as come they someday surely will, or past successes are no index to the future. When they do come, however, the necessities of the case will make them metaphysical. Meanwhile, the best way in which we can facilitate their advent is to understand how great is the darkness in which we grope, and never to forget that the natural science assumptions with which we started are provisional and revisable things." End of quote. And end of chapter 1. Meet me at the next video as we continue with cosmos, the soul, and God, and let's find out what the author has to say on the nature of ether, also his idea of the stages of development of the organic world, and man as more than a corporeal being. All right.